This lesson is on energy conversions. The standards addressed in this unit: science, practice, and thinking. The students will use the scientific method to design and execute their own experiment. Physical science standards. The students must understand the processes involved in the transfer and conservation of energy. On the left side page of your notebook, start with this quick write. What are all the energy conversions that take place for you to eat an orange and then go score a soccer goal? Pause the video to make your own list of as many energy conversions as you can think of. Set up the right side page of your notebook for Cornell note-taking. The essential question: how do energy conversions make energy useful? The first term, energy conversion. Energy conversion is a change from one form of energy to another. Like in our bouncy ball example. We started with potential energy, and as I gave it a toss, it changed from kinetic to potential, back to kinetic, and so on and so on. We can map this energy conversion in a flow map. In our bouncy ball system, we started with potential energy. As I gave it a toss, it converted to kinetic energy. And then at the peak, it was back to potential energy. As the ball fell toward the earth again, it converted to kinetic energy. And then as it hits the floor, there's a few more things going on. We know that there's potential energy as the ball compresses a little to the floor. But we can hear the sound energy. And we also know that through friction, that there will also be heat energy converted. Now the sound energy and the heat energy do not go back and convert into kinetic energy for the ball to move back up. Only the potential energy is able to convert back to the kinetic energy. This is why the ball does not bounce all the way up to the original height. I start here, the ball does not return to my hand, because some of the energy from the ball is being converted to sound energy and heat energy, and the ball is not able to travel all the way back up. So then the system continues kinetic, potential, and so on. Can you identify which energy conversions are present in this system? Pause the video to make your own predictions. If we start with the battery, we'll have chemical potential energy that is stored in the battery. As the electrons leave and travel through the wire, we have electrical energy. That electrical energy reaches the light bulb, and we will see the light energy. But then also some of this energy from the light bulb will also be converted to heat energy. Can you identify the energy conversions that take place in photosynthesis? In your notes, on your right side page, draw a flow map to map the conversions of energy in the process of photosynthesis. If we start from the sun, we know that the sun is nuclear energy releasing to light energy. The light reaches the leaf, and that light energy is then converted to chemical potential energy. That chemical potential energy is stored in carbohydrates, and when organisms like us eat them, it goes from chemical energy to kinetic energy to power our bodies, but then also much of the energy that we consume from our food is actually converted to heat, so it would be chemical to heat. So going back to our energy diagram, we've started at the sun with nuclear energy, and then it was converted to light energy. That light energy was taken in by the leaf, converted to chemical potential energy, and then when those carbohydrates are consumed, that chemical potential energy is used as kinetic energy, but then also some of that energy is converted to heat. Thinking about this system with the sun, Did all of the nuclear energy from the sun end up as kinetic energy in our bodies? Of course not. Step by step by step, some of this energy is converted to other forms and lost out of the system. That takes us to this law. We have to remember the law of conservation of energy. Energy cannot be created or destroyed. It is only changed from one form to another. So when we think about the bouncy ball example and why the ball will not return all the way to our hand, it's not that the energy was destroyed. The energy was simply converted to another form, and it wasn't useful in getting the ball to bounce all the way back up. Here we have another example of a roller coaster energy system. 3 types of energy will add together to equal the original amount of potential energy that the roller coaster has at the top of its first hill. Pause the video to make your own prediction. The 3 types of energy that will be equal to the original potential energy are the kinetic energy of the motion of the roller coaster, the heat energy that's released by friction, and the sound energy that's released from the vibrations of the cart against the track. Our final term, energy efficiency. Energy efficiency is the comparison of the amount of energy before and after an energy conversion. For example, humans are not energy efficient. 95% of the energy that we get from our food is actually converted to heat, not the kinetic energy used to power our bodies. Cars are more energy efficient than humans. Of the gasoline that a car will consume, the energy, most of it is converted to heat, but at least 22% of that energy is converted to the kinetic energy used to power the car. So what type of energy is always a product in an energy conversion? Well, I hope you said heat. In the example of the bouncy ball, we've got friction between the ball and the ground that will release energy as heat. In the example of the light bulb, some of that energy is converted to heat. In the example of the roller coaster, the friction of the car against the track is going to release some of that energy as heat. Your assignment is to take an energy system and map the conversion of energy step by step by step. You cannot use the bouncy ball example, but any other example is fine, including the one from your quick write, where you eat the orange and go score the soccer goal. When you're done mapping the energy conversions of your energy system, be sure to answer this frame of reference question. Where is energy lost in the system? I want you to think about this idea and relate it back to the law of conservation of energy. And finally, to finish this set of notes, you need one level 2 Cornell question and then a summary.